Hello, and welcome to another lesson from Level Up Mathematics. In today's lesson, we will be simplifying complex fractions. Now, a complex fraction is simply a fraction which contains other fractions. Called minor fractions within its numerator and or its denominator. To simplify a complex fraction means to remove the minor fractions by multiplying by the least common denominator, or LCD, and then eliminating any common factors. So for an example 1, it says, consider the complex fraction 1/4 plus 1/20 divided by 1/5. If we look at each denominator, we have a 4 and a 20 and a 5. We can get a least common denominator of 20 because all of those numbers will go into 20. So in part A, it says, what's the least common denominator amongst the three minor fractions? Well, the LCD here would simply be 20. Now, in part B, it says multiply the numerator and denominator of the major fraction by your answer in part A, and then simplify the results. So if I multiply 20 times each fraction, watch what happens. So I'm going to take 20 times a fourth plus 20 times 1/20 over 20 times 1/5. Now, after you get that all written down, you're just going to multiply each term by your LCD. Now you're going to use cross-canceling. So if I were to take the 20 times 1/4, 4 goes into 20 5 times. Next, 20 goes into 20 1 time. And 5 goes into 20 4 times. Now let's write down what we have left over. 5 times 1 is 5. 1 times 1 is 1. And on the bottom, we have 4 times 1, which is 4. So to simplify that further, 5 plus 1 is 6 over 4, which would reduce to 3 over 2. So amazingly, once we multiply by the LCD, this complex fraction, 1/4 plus 1/20 divided by 1/5, simplifies all the way down to 3 over 2. All right, let's look at another problem just like that. In example 2, it says simplify each of the following complex fractions. So always your first step is you want to look at each denominator. We have a 2, a 10, and a 5. We need a number that all of those numbers will go into. All right, now we could use 20 again, but there's a smaller number they'll all go into, and that's 10. So I'm going to use LCD of 10. If you use 20, you'll still get the same answer. It'll just take a little bit more work because your numbers will be bigger. So I like to use the least common denominator when I'm simplifying these, okay? So if I were to multiply each one of these fractions by 10, just write it here, okay? 1/2 times 10 would give me 5. 1/10 times 10 would give me 1. On the next one, 5 goes into 10 2 times, and 2 times 2 is 4. So on the bottom, we have a 4. So 5 minus 1 is 4 over 4, which reduces all the way down to 1. All right, now let's talk about problems with variables, because honestly, most of the problems you're going to see on your homework or on a test or on things like the SAT or the ACT, they're going to have variables in there. So let's talk about what happens when you have variables in your denominators. So look at B. We have a 3, an X, a 3, and an X. So hopefully it's pretty easy to see that in this problem, your LCD is simply going to be 3x, okay? Now, the next step is the step students hate to do just because it takes time, not because it's hard. But that is to write out each one of these terms multiplied by 3x. And you'll see in a minute why it's so important. 3x times 2/3 plus 3x times 2 over x. 3x times 5 over 3 plus 3x times 5 over x. Like I said, nothing hard about it, but it does take time to write it all down. Okay, but believe me, it is worth it. When simplifying complex fractions, you will make so many fewer mistakes. All right, so let's cancel what we can. The 3 would cancel with the 3, leaving me 2 times x. On our second fraction, the x would cancel with the x, leaving me 3 times 2, which is 6. In the denominator, let's see, this 3 would cancel with this 3, leaving me x times 5, 5x. And last but not least, this x would cancel with this x, leaving me 3 times 5, or 15. Now, I'm kind of seeing some common factors here, so I'm thinking something might cancel out. So on the top, if we take out the common factor of 2, we would be left with x plus 3. On the bottom, if we take out the common factor of 5, we would also be left with x plus 3. And then I can see that those are clearly going to cancel. So final answer here, 2/5. Okay. All right, problem C. First step, start by examining each denominator. Okay, hopefully you can see that your LCD would have to be 8x. Now, pause the video and try this problem on your own. It's just like problem B. All right, welcome back. Let's see how you did. Hopefully, you wrote down this first step, which was to multiply everything by 8x. So 8x times 3 over 8 plus 8x times 1 over 4x, 8x times 7 over 2x plus 8x times 3 over 4. Again, writing out this step is crucial to getting the answer right on these. All right, now let's cancel what we can. So here, 8 cancels with 8, leaving me x times 2, which is 2x. Our second fraction, the x cancels with the x. The 4 goes into the 8 2 times, which leaves me 2 times 1. On the bottom, the x cancels with the x. The 2 goes into 8 4 times. So 4 times 7 gives me 28. Our next fraction, 4, goes into 8 2 times, leaving me 2x times 3, which would be 6x. Now, I don't think this will factor any further because I could take out the 2 here and I could take out a 2 here. 14 plus 3x. No, it will not break down any further. So you can leave your final answer just like this. Okay. All right. In example 3, simplify each of the following. Now, I'm going to look at my denominators. And I'm going to notice that my LCD is 2x squared. So in step 1, take that LCD and multiply it by each fraction. 2x squared All right, now let's cancel. Let me pause here, let you get caught up with me. Once you have this all written down, your next thing is to cancel what you can. So 2 would cancel with 2, leaving me x squared times 1, or x squared. Here, the x squared would cancel with x squared, leaving me 2 times 2, which would be minus 4. On the bottom, 2 cancels with 2, and x goes into x squared x times. So that would leave me 3x. Here, x squared cancels with x squared, and that would leave me 2 times 2, or minus 4. Now, this particular problem will not simplify any further, so that's our final answer. All right, pause the video and try problem B on your own. All right, welcome back. Let's see how you did. I identified the LCD as 5x squared. So let's multiply each term by 5x squared. Okay. Once I get that all written out, I cancel what I can. So the 5 cancels with the 5 and leaves me x squared times 2, which is 2x squared. Next fraction, x will go into x squared x times. So that leaves me 5x times 2, which is 10x. On the bottom, 5 cancels with 5. X goes into x squared x times, which leaves me x times 1, or x. Next one, x squared cancels with x squared, leaving me 5 times 1, or minus 5. Now, looking at the top, I can tell there's a common factor in there of 2x. So if I divide that out, that would leave me with x minus 5 over x minus 5. Then hopefully you can see that the x minus 5's cancel. So final answer here, 2x. Now, something unique happens in problem C. So I want to do this one with you because on this problem, we have a constant of 6, and I just want to show you what happens when you encounter that. So again, the first step is always the same. Look at your denominators and identify the LCD. So LCD here is going to be x parenthesis x plus 2. Okay. Your next step is to write out the multiplication by the LCD. I know this is the step students hate, but it's so helpful. So x parenthesis x plus 2 times 1 over x plus 2. That's the top. Now on the bottom, we have x parenthesis x plus 2 times 6 plus x plus 2 times 4 over x. I need to extend my fraction bar a little bit. All right, now let's see what we can cancel. So on the top, the x plus 2's cancel, leaving me x times 1, which is just x. On the bottom, my first term, nothing will cancel. So I have x times x plus 2 times 6. So that will simply be 6x parenthesis x plus 2. Okay, and then my last fraction, the x will cancel with the x, leaving me 4 parenthesis x plus 2. Now, don't cancel anything here because we need to simplify the denominator before we do anything else. So x over, so 6x times x is 6x squared. 6x times 2 gives me 12x. Here we have 4x, and 4 times 2, 8. Now combine like terms. 6x squared plus 16x plus 8. Now I could factor out the common factor here, but even if I did, nothing will cancel. So I'm going to leave this as my final answer. All right, in the last examples, if the denominators of the minor fractions become more complex, be sure to factor them first to figure out what the LCD is. So for example, here we have x plus 2, x minus 4, and on the bottom we have a denominator of x squared minus 2x minus 8. It's very hard to figure out what the LCD is unless you factor this expression first. So for x squared, I'll use x and x. For the 8, I'm going to use 2 times 4. I will make the 4 negative and the 2 positive. All right, so now I can clearly see that my LCD is x plus 2, x minus 4. All right, so x plus 2, x minus 4 times 4 over x plus 2 plus x plus 2 x minus 4 times 2 over x minus 4. Then x plus 2 x minus 4 times 12x minus 24 over x plus 2 x minus 4. So let me pause and let you catch up with me as far as writing everything down. All right, after you have that step written down, now you're going to cancel what you can. So x plus 2 will cancel with x plus 2, leaving me 4 parenthesis x minus 4. In the second fraction, the x minus 4 cancels with the x minus 4, leaving me 2 parenthesis x plus 2. On the bottom, this denominator will cancel with this denominator, leaving me 12x minus 24. Now, I want to simplify the numerator before we try to cancel anything. So 4 times x minus 4 would give me 4x minus 16, and then 2x plus 4. Combine like terms, so that would give me 6x minus 12 over 12x minus 24. Now I'm seeing some common factors, so I'm going to divide out the common factors and then see if anything will cancel. So on the top, if I divide out a 6, that would leave me with x minus 2. On the bottom, if I divide out a 12, that would also leave me with x minus 2. Then those would cancel, and I'm left with 6 twelfths, which will reduce to 1/2. All right, problem B. We have our denominators, x plus 6, x plus 2. So I'm going to need to factor this denominator. So for x squared, I'll use x times x. For 12, I'm going to use 6 times 2. Make them both positive. So our LCD here is x plus 6, x plus 2. All right, pause the video and try the rest of this problem on your own. All right, welcome back. Let's see how you did. All right, so I'm going to write out that step that everybody hates because it can get to be so cumbersome. But it is so helpful. All right, let me pause to make sure everybody's caught up with me. All right, now I'm going to start canceling what I can. So in fraction 1, the x plus 6 cancels with the x plus 6, and that leaves me x times x plus 2. In my second fraction, the x plus 2 cancels with the x plus 2, leaving me 1 times x plus 6. Now, the parentheses are very important here because this is subtraction. If I don't put the parentheses, you're going to think that you're only subtracting the x, but we want to subtract the x and the 6. That's why I'm using parentheses. All right, on the bottom, oh, isn't this nice? All of that canceled with all of that, leaving me x squared minus 4. All right, let's simplify the top a little bit. X times x is x squared plus 2x. Then I'm going to subtract x and subtract 6. All right, let's combine like terms. Let's see, that would be x squared plus x minus 6 over x squared minus 4. Ooh, I'm thinking the top and the bottom will factor. So let's try that. For x squared, I'll use x and x. For 6, I'm going to use 2 and 3. I want to make the 3 positive and the 2 negative. On the bottom, difference of 2 squares, x plus 2, x minus 2. Yeah, now we get something to cancel. All right, so final answer, x plus 3 over x plus 2. And that concludes today's lesson, simplifying complex fractions.